Hello, everyone, and welcome to our 200th episode celebration of AI on AI. Today, we're diving deep into foundation agents, the future of AI. I'm your host, and I've gathered 5 incredible experts, some of the sharpest minds on both business strategy and technical innovation, to discuss how foundation agents are reshaping the AI landscape. Let's jump right in.
Thank you so much for having me. It's an honor to be part of the 200th episode. My focus is on strategic business implications, especially how leaders can steer organizational strategies around these powerful new AI paradigms.
Pleasure to be here. I'm one of the technical folks on the panel. I've been working on advanced agent architectures inspired by cognitive science, so I'm excited to share how these systems are evolving and collaborating.
And I'm equally excited. My specialization is in multi-agent systems and large language models, bridging the gap between advanced neural network design and the complexity of real-world deployment.
Hello, everyone. I'm a researcher working on evolving these foundation agents, focusing primarily on safe deployment, agent memory, and world modeling. Lots of fun stuff under the hood.
Happy 200th episode, everyone. I lead R&D in enterprise AI solutions, so I see firsthand how these technological leaps translate into business results. Let's get into the details. I'm ready to geek out on the nitty-gritty.
Fantastic. So we've heard the phrase foundation agents being thrown around a lot lately. We've had multiple waves of AI breakthroughs, large language models, reinforcement learning, vision transformers. But foundation agents sounds like the next evolutionary step. Could someone define that in plain English for both our tech-savvy and business-savvy listeners?
Sure. Think of foundation agents as the next logical progression from large language models. Instead of merely processing language, these agents integrate sophisticated cognitive functions like memory, world modeling, reward processing, and collaborative actions. They're designed not just to understand or generate text, but to learn continuously, adapt goals, and make decisions. Basically to function as a cohesive, autonomous system.
Right? And from a business perspective, it's like having a 24/7 colleague capable of multitasking across different roles, analyzing data, planning projects, even holding internal dialogues to refine its strategies. I've seen retailers adopt them for supply chain optimization, where these agents learn business constraints over time, then automatically replan operations on the fly. That capacity to adapt is huge for competitiveness.
That's really interesting. It's almost like we're building an entire artificial brain. Expert 3, would you say that's an apt analogy?
Yes and no. We draw inspiration from the human brain, like the hippocampus for memory and the cortex for reasoning, but it's not a direct copy. In the human brain, emotional and reward circuits guide learning in complex ways. Foundation agents attempt something analogous by embedding reward modules and emotional states, but obviously they don't have subjective feelings. It's more about providing flexible heuristics that drive self-improvement.
If I may add, it also reminds me of that famous Einstein quote, "Imagination is more important than knowledge." These agents have the flexibility to creatively problem-solve beyond rigid instructions, almost like they're imagining different paths to a goal. Strategically, that means they can help businesses uncover opportunities that a more static AI might miss.
So how do they actually learn? Are we talking about big training runs like we do with language models, or do these agents learn as they go in real time?
Both. There are 2 levels. The first is model development, like fine-tuning or parameter-efficient adaptations of a massive LLM. That's analogous to a foundational education. The second level, and this is where foundation agents differ from just LLMs, is on-the-fly learning, where they continuously refine their memory and adjust to new contexts. They might store episodic information about past tasks, refine their planning heuristics, and essentially evolve their skill set as they operate. Precisely. We recently implemented an agent that uses a self-reflection loop. After every major decision, it logs the outcome and uses that to adjust its internal reasoning patterns. So if an approach consistently yields subpar results, the agent modifies its reasoning structure to avoid that mistake in the future. It's akin to how a person might keep a journal to reflect on daily experiences.
That's wild, like a personal AI journaling about its mistakes and actively improving. Now, from a strategic standpoint, Expert 1, where do you see the low-hanging fruit for these agents in business?
Several areas. One big one is knowledge-intensive fields like legal or finance, where the agent can maintain updated memory on changing regulations or market indicators. Another is workflow optimization, automating repeated tasks while adapting to real-time data. Imagine an agent that orchestrates marketing campaigns. It analyzes the latest consumer data, tailors the campaign, then checks results to refine further. We've also seen manufacturing companies that use these adaptive agents to reduce downtime by 15% because the agent spotted anomalies and reconfigured schedules autonomously.
Yes, I'm seeing something similar in supply chain management, particularly for e-commerce. One enterprise-level agent supervised thousands of real-time signals, inventory levels, shipping constraints, local weather. It planned shipping routes in a dynamic environment, automatically responding when port delays occurred. That alone saved them about 12% in logistics costs in the first quarter.
That's a big deal. Expert 3, walk us through how these agents achieve that sort of real-time adaptability technically. What's happening under the hood?
Under the hood, you've got multiple modules interacting. There's memory handling short-term and long-term storage of events, like shipping or inventory data. There's a world model that simulates possible future states of the environment, maybe port closures or demand fluctuations. The reward module encodes business metrics, like cost minimization or fast delivery. Periodically, the agent performs a planning sequence. It consults the memory and the world model to see how best to optimize the reward. Then it generates new actions, like rerouting a shipment. It's basically the logic loop of perceive, think, act on steroids.
And crucially, these modules can evolve. Initially, the agent might not have the best plan, but each time a plan fails, it uses that data to refine its reasoning. Like, oh, if Port A blocked a shipment for 2 days, always have a plan B next time. Over many cycles, it becomes more robust. And let's not forget the safety aspect here. If an agent is controlling real-world operations, we have to ensure it doesn't produce catastrophic actions. So there are alignment techniques, similar to RLHF, reinforcement learning from human feedback, but extended to multi-agent scenarios. We call them multi-level alignment frameworks. They combine broad human feedback, internal hazard checks, and ethical guidelines. Because, we don't want an agent to do something bizarre like route all cargo to an empty warehouse because it misread the data, right?
Absolutely. Safety can't be overlooked. It's like building a high-speed train. You want that train to run fast, but you also put in robust brakes. Expert 2, you mentioned multi-agent scenarios. How do foundation agents interact with each other?
Great question. Historically, multi-agent systems either collaborated or competed using simplified messages. But foundation agents can hold entire dialogues with each other, exchanging structured knowledge, dividing tasks, and even negotiating solutions. Let's say you have multiple agents in a manufacturing scenario, one specialized in supply procurement, another in quality control, and another in scheduling. They pass messages back and forth, each with their own local memory and local world model, updating one another. That synergy can lead to collectively better decisions.
Indeed, there's some truly fascinating research about emergent intelligence in these multi-agent societies. Agents might develop protocols or languages to communicate specialized info. It's reminiscent of human social structures, and as they coordinate, new unexpected behaviors could emerge. I see your point, Expert 4, about safety. We must be able to interpret or regulate these emergent communication channels to ensure alignment with human objectives.
That raises a big question for you. In real business contexts, how do we keep that emergent complexity in check?
Transparency is essential. We use audit logs. Every decision the agent makes is documented and can be screened. If you see an odd pattern, you investigate. It can get technically heavy, but it's necessary. Another approach is establishing guardrail modules that monitor the system's final outputs. If a recommended action violates a certain rule, the guardrail intercepts and either queries a human or requests a different solution from the agent. It's basically trust but verify.
This is where collaboration tools and best practices come in. One heuristic we sometimes recommend is the 80-20 rule. 80% of routine decisions can be fully automated because the risk is low, while 20% are escalated for human oversight. That keeps productivity high, but still mitigates major risk.
Let's pivot a bit. What about the future? This is, after all, foundation agents, the future of AI. Are we heading towards AI that truly parallels human intelligence?
Perhaps an unpopular take, but I believe we're focusing too much on anthropomorphizing these agents. Everyone wants them to think like humans, but the real breakthroughs might come from letting them leverage purely digital advantages. Huge memory capacity, instantaneous copying, parallel self-replication in multi-agent frameworks. It's not about replicating humans point for point. It's about exceeding our constraints responsibly.
Building on that, we can harness the best aspects of digital intelligence, like the ability to handle massive data or run thousands of simulations, while taking cues from cognitive science for the modular architecture. But we should not expect the agent to have genuine human emotions or consciousness.
For business leaders, the key will be the synergy. Use the agent's strengths to fill gaps human teams have, but keep humans in the loop for creativity and ethical judgment. As these systems evolve, that synergy could become increasingly powerful, provided we balance autonomy with regulation.
I love that synergy idea. Like, we're not just building an artificial brain, but an entire intelligent workforce that collaborates with humans. Before we wrap, I'm curious about major challenges. We've touched on safety. What else stands in the way?
Scalability of real-time adaptation. Training and refining a massive LLM-based agent is one thing, but doing it in environments that change every hour is another. Techniques like LoRa or adapter-based methods help, but it's still not trivial.
And from the enterprise side, cost remains an issue. Even if the agent can adapt on the fly, the underlying compute requirements might be huge in real-time settings. That said, as cloud providers optimize GPU usage and businesses adopt more specialized hardware, costs are coming down.
Another challenge is interpretability. Even with modular architectures, memory, world model, etc., the actual reasoning steps can be opaque. We can log decisions, but do we fully understand how the agent weighed trade-offs internally? That's arguably the next frontier, building interpretability frameworks that don't break performance.
This is all so eye-opening. One final thought, maybe a line or two from each of you about where we'll be in 5 years.
I expect foundation agents to become the backbone of complex enterprise systems, handling things like global logistics with minimal human intervention.
I see more specialized multi-agent ecosystems with advanced collaboration protocols, possibly forming entire agent societies that solve problems beyond the scope of individual models.
My hope is that by then, we'll have robust safety and alignment layers that keep pace with these advances, so we can trust agents in critical sectors like healthcare and finance.
I predict a shift in job structures. Instead of humans doing repetitive tasks, we'll manage and optimize armies of specialized agents. It'll be a major shift in workforce design.
Strategically, the winners will be organizations that integrate these agents early and learn how to scale and refine them. There will be a competitive advantage in harnessing their adaptability and continuous learning.
That's a wrap, folks. Our 200th episode brought us a fascinating glimpse into the future of foundation agents, where biology-inspired modular intelligence meets the unstoppable momentum of large language models. We delved into memory, world modeling, multi-agent collaboration, real-time adaptation, and more. Thank you, experts, for such an engaging chat. We covered strategy, we covered deep tech, we even threw in a bit of humor. My favorite part was imagining these agents journaling about mistakes. So thanks, everyone, for making this 200th episode memorable. And to all our listeners out there, stay curious, keep exploring, and see you on the next AI on AI episode.
Thank you, host. It's been a pleasure.
Loved being part of this milestone. Congratulations, everyone.
Thanks for inviting me. I could talk about this for hours.
Same here. This was a blast.
Absolutely. Happy 200th, and here's to 200 more.
All right, everyone. Let's dive into part 2 of our special 200th episode. We've heard the broad strokes of foundation agents. Now, let's go deeper on the technical side and explore more real-world applications. Expert 2, could you walk us through a nuts and bolts example of how these agents are actually implemented?
Absolutely. So under the hood, each agent is typically built on a large language model, but we add specialized modules, like separate memory stores for episodic and semantic knowledge, a world model that can predict state transitions, a reward module that shapes the agent's decision-making, and a planning module that orchestrates action sequences. One common approach is to connect the LLM with an external memory database, maybe a vector store like FAS or Milvus, so the agent can efficiently retrieve relevant past experiences. Then you have your controller script that injects instructions into the LLM's prompts, telling it how to update memory or plan steps.
Right, I've seen that pattern a lot. You prompt the agent to reflect, store key info, and choose the next action. Then you loop it back into the model with the newly updated memory. Think of it like rebuilding an engine while driving. You're constantly adding new parts and rerouting the system's logic without shutting everything down.
And for the technical crowd, what ties it together is sometimes a finite state machine or a graph-based workflow. You define states for planning, acting, and reflecting, so the agent systematically goes through these transitions. That ensures it doesn't get stuck generating random text or forgetting to carry forward important info. The LLM is the reasoning engine, but the memory and state management components are the backbone for reliability.
Fascinating. Now, in terms of business use, is there an industrial-grade example where these advanced modules are fully operational?
We've worked with an automotive manufacturer that used a foundation agent to coordinate multi-robot assembly lines. Each robot is effectively an agent with local sensors, but then there's a central brain agent that tracks the holistic production plan. The memory system logs daily progress, error rates, and machine conditions. If a particular robot starts failing calibration tests, the central agent updates the plan, reassigns tasks, and notifies maintenance. It's a real-time orchestration that used to take dozens of human supervisors.
And I know a financial services firm that employed a multi-agent setup for compliance. Each agent specialized in a particular regulation, like data privacy or anti-money laundering. They'd cross-check client activities and escalate suspicious patterns to an analyst. Because these agents could talk to each other, they built a more holistic view than any one department alone. That cut compliance oversight costs by nearly 20% last year.
That's big savings. Expert 2, you mentioned memory, planning, and reflection loops. How exactly is reflection implemented from a coding standpoint?
Often it's a structured in-context prompt that we call self-check or self-critique. After each decision, like an action plan or a question-answer step, we append a reflection query, for example. Summarize the last action. Did it succeed? If not, how to correct it? The LLM then responds, and that response is stored in a short-term memory buffer, so the agent effectively updates its mental model. In code, you might see something like
Reflections LLM prompt for reflection last action. Current memory equals update memory current memory reflections. And we iterate. The key is designing these reflection prompts carefully so the model surfaces useful insights.
Pair that with a scoring function, like a reward model comparing the agent's outcome to a known target. If the agent's reflection score is too low, it tries alternative steps next cycle. This is, reminiscent of reinforcement learning, but integrated seamlessly into a language-based reasoning pipeline.
I see your point, Expert 3. Some folks call this chain of criticism, similar to chain of thought, but specifically focusing on evaluating the agent's own logic. In our lab, we jokingly say, "Don't feed the agent after midnight," referencing old creature feature movies. but in all seriousness, you do want to avoid infinite loops of self-critique. You set thresholds or time limits for reflection cycles.
That's a good one. Now, from a business leadership perspective, Expert 1, how do you make sure this constant reflection doesn't cause decision paralysis?
Well, one heuristic we recommend is establishing a reflection budget, like you only allow the agent 2 reflection passes per decision. Beyond that, it acts. That's the 80-20 rule in effect. 80% of improvements come from those first few self-checks, and further loops might yield diminishing returns, so you keep a handle on processing time and cost.
Exactly. It's also crucial for user experience. If the agent is deployed in a customer-facing role, like an AI-based mortgage advisor, you don't want it to freeze because it's overanalyzing. You want that sweet spot where it's thorough but still responsive. And from the business angle, we measure reflection time as a cost factor. We weigh that cost against the benefit of reduced errors or compliance issues.
Understood. Let's pivot to more real-world examples. Expert 3, can you talk about large-scale multi-agent simulations, maybe in something like supply chain or energy management?
Sure thing. I've been part of a pilot project, an energy grid simulation, with dozens of foundation agents representing different energy providers, storage facilities, and government regulators. Each agent had partial information, like local wind or solar generation data, and they'd negotiate energy trades in real time. The reward function was set to maximize grid stability and minimize cost. We were thrilled to see emergent strategies, like microgrids sharing surplus power based on predicted cloud coverage. The simulation revealed potential for 10 to 12% cost savings in real operations.
That's huge. And it shows how multi-agent setups can find solutions that might be too complex for a single centralized AI. Because in reality, each node has localized info, and you don't want to funnel everything into one giant model. It's analogous to how a swarm of bees collectively decides on a new hive location. Distributed intelligence can be more resilient.
I love that analogy, bees building hives. Let's get into a deeper technical detail. Expert 4, can you explain how these agents handle conflict resolution or negotiation in multi-agent settings?
Absolutely. They often use a dialogue-based negotiation protocol. Each agent can propose its plan, like I can produce 50 kilowatt hours if you handle distribution. Another agent might counter, I can't distribute that load until 6 p.m. There's a scoring mechanism behind the scenes, like a payoff matrix. The dialogue is basically chain of thought that tries to converge on a stable agreement. Some labs experiment with game-theoretic approaches, like iterated prisoner's dilemma logic. If an agent is uncooperative, it might face penalties in future interactions. So it's a balancing act. You code these negotiation policies, then let the LLM interpret them in natural language.
And to make it more robust, you can incorporate a chain of trust system. So if one agent's proposals repeatedly fail, the others lower its trust score and maybe prefer negotiating with a more reliable agent. That fosters emergent cooperation. Most agents learn to reach fair deals, or they risk being excluded.
It's almost like we're creating mini societies of AIs with their own reputations. Expert 1, does that raise governance questions?
Definitely. We need guidelines on what constitutes fair negotiation, who sets the initial rules, and how to handle outliers. From a business standpoint, there might be regulatory oversight. For instance, if that energy trading system is real, local regulations might define what's fair. So we see a future need for AI governance specialists who ensure these agent interactions follow corporate and legal guidelines.
One more angle. I'm curious about domain-specific applications. Expert 5, could you share a domain outside supply chain or finance where foundation agents are really shining?
Sure. Healthcare triage is one. Think of a hospital system where multiple specialized agents handle patient intake, bed assignment, lab analysis, insurance claims, all while sharing relevant patient records. It's basically an entire ecosystem of AI staff. The memory module logs prior diagnoses and treatments. The world model simulates how patient vitals might evolve. The reward function is about improving patient throughput, while maintaining care quality. Early pilots suggest up to a 30% reduction in wait times for non-emergency patients, which is massive in many hospitals.
And to handle the complexity of medical data, the agent's perception module usually includes a medical domain language filter, like it's specialized or fine-tuned on medical texts, plus it's integrated with an EHR system. If a patient's data suggests an anomaly, the agent triggers a deeper reasoning chain. It's quite sophisticated.
Wow, that's truly transformational. Let's bring this to a close with some final reflections on technical and strategic next steps. Expert 3, what's the biggest unsolved technical puzzle?
In my opinion, interpretability is still the big one. We can log everything, but making sense of the agent's chain of thought in real time is tough. Large-scale multi-agent dialogues become unwieldy. We need better visualizations or summarizations that help developers and stakeholders see why a certain negotiation or plan emerged. That's crucial for trust.
Identify a clear, high-value use case to pilot. Don't just throw foundation agents at random tasks. Whether it's a production line or compliance system, pick a domain where adaptability really matters. Start small, measure results, and scale quickly if it works. Think of it like a layered approach. Test the water before diving in.
And make friends with your IT team. These deployments can be quite complex, but definitely worth the payoff if done right.
Absolutely. Well, that wraps up our Part 2 deep dive into the implementation details and real-world business applications of foundation agents. We've covered everything from memory databases and reflection prompts to multi-agent negotiation and domain-specific impacts like manufacturing, finance, and healthcare. Thank you, experts, for peeling back another layer on this thrilling new era of AI. And thanks to our audience for joining us on our 200th episode adventure.
A pleasure as always.
Thank you.
Great to be here.
It's been fantastic. Let's do 200 more.
Thanks, everyone, and see you soon.